Good morning, children. Let us start with a new topic, number system. Before we start, we must see what are the main concepts in this lesson. First, we have to recall natural numbers, whole numbers and integers. Second one, classify rational numbers as recurring and terminating decimal. Third one, to understand the existence of non-terminating and non-recurring decimals. Fourth one, to represent terminating and non-terminating decimals on a number line. Fifth one, to understand the four basic operations in irrational numbers. Sixth one, to rationalize the denominator of the given irrational numbers. And finally, laws of exponents for real numbers. Let us recall what are the things we studied already. Okay, so first I am asking you what are different categories or different types of numbers you studied till 8th standard. We studied natural numbers, whole numbers, integers, rational numbers, isn't it? So first let us see what is meant by a natural number. The counting numbers 1, 2, 3, etc. are called natural numbers. It is represented by the letter N. Whole numbers. The set of all natural numbers together with 0 forms the set of whole numbers. It is represented by the letter W. So my question is, whether every natural number is a whole number, children? Yes. Why? Because whole number contains 0, 1, 2, 3, etc. Isn't it? So every natural number is a whole number. Is the converse true? That means every whole number is a natural number? No, never. What is the reason? Because 0 is not in natural numbers, isn't it? So, every natural number is a whole number, but every whole number need not be a natural number. The third type we studied as integers. What is meant by integers? All positive numbers, negative numbers together with a 0 we called as integers. Can you say what is the representation of integers? Z, isn't it? So Z, what is the representation of integers? Z. Z is derived from the German word zählen. It means to count. So every natural number is an integer. Every whole number is also an integer. Okay. Next let us see rational numbers. A number of the form P by Q where P and Q are both integers and Q should not be 0 is called a rational number. Can you say examples? Lot of examples you can say, isn't it? 3, that is 3 by 1, minus 5 by 8, 7 by 8, 9 by 3, 4 by 2, 7 by 2. All that are examples of rational numbers. So we can say that a rational number may be positive, negative or 0. So 0 is a rational number. Is 0 is a rational number? Yes. How you can represent 0? 0 is same as 0 equal to 0 divided by 1 or 0 divided by 2. Isn't it? But the denominator 0 comes means it is not defined. Okay? Division by 0 is not defined. That is the reason they are given that the denominator q should not be 0 in the definition of rational numbers. Clear, children? Next, let us see the decimal representation of rational numbers. So, in smaller classes, you studied long divisions and all, isn't it? So, if we are dividing a number by another number, sometimes we will get the remainder as 0. Sometimes we will get the reminders in the other than 0. isn't it? So let us see the two cases. Case 1, the remainder becomes zeros. So when the decimal expansion of p by q terminates, that is, it comes to an end, the decimal expansion is called terminating decimal expansion. So what is the meaning of terminating decimal expansion? Some extent, the division come to an end, isn't it? So we will get the remainder as 0, then only it will terminate, isn't it? Otherwise, if we are having some other numbers as a denominator, the division will go on continuously, isn't it? So the first case is the remainder becomes 0. If the remainder becomes 0, the decimal expansion we called as a terminating decimal expansion. Understood clearly, children? What is the second case? The remainder never becomes 0. So we can see with different examples. 5 by 11, 7 by 6, 22 by 7, etc. So you find out the division, long division in your rough paper and see that what is the remainder you are getting in each cases. Is it 0? No, never. Isn't it? So in the first case we are getting the remainder as 5. The second case we are getting the remainder as 4. The third case we are getting the remainder as 1. So 5 by 11 we can write 0.4545 etc. So here 4, 5 are the two digits repeatedly coming. Okay. So how you can write this as 5 by 11 equal to 0.45 bar. That means 4-5 digit above you must put a line that we called as a bar. That means that two digits are repeatedly coming. Next you see 7 by 6. How you got the decimal expansion? As long division we proceed, we got that as 1.1666 etc. So 6 is the digit is repeatedly coming there. So how you can write 7 by 6? 7 by 6 is equal to 1.16 bar. Above the 6th alone you put a line that is bar. That means the digit 6 alone repeatedly coming. So this type of decimal expansion of a rational number need not terminate. That means it will not have a end point, isn't it? So in that cases we observe that the remainders never becomes 0. So this type of decimal expansion we called as non-terminating and recurring. So what is meant by non-terminating and recurring? In the decimal expansion of p by q, when the remainder never becomes 0, we have a repeating block of digit in the quotient. In this case, the decimal expansion is called non-terminating and recurring.